time. Just ahead of time, what we normally like to do, normally request, although I think Willie could go either way with it. Since it's a little hard to tell if anybody has a particular question, one of the things we try and do is, as well as mute everyone who's not presenting, we also ask that you turn off your video so that if you do have a question, turn on your video and your microphone, and we will recognize you. It's easier to see somebody pop up that way. So with that, I'll hand it over to Alex to introduce our speaker for the evening.
Okay. Willie Yee is our speaker tonight. He is an amateur astronomer, past president, and member of the board of directors of the Mid-Hudson Astronomical Association. He presently is a Solar System Ambassador, a program supported by NASA and the Jet Propulsion Laboratory in Pasadena, California. His other interests include magic, bicycling, and jazz. Take it away, Willie.
Okay, let's see. Oh, let me get up. I have a moon for you. There we go. Okay, so I need to be able to share my screen here. Are we on? There we go. Can everybody see that? You're all muted, so if you can't hear me, unmute yourself and scream.
We can see it.
It is very
I hear no screams. Okay, just to remind you what solar system ambassadors are volunteers. I like to call us cheerleaders for NASA. We are supported by NASA and JPL. We get educational events and briefings by the mission scientists, usually when there's a launch or a new project going up. That being said, my views do not represent that of NASA or the Jet Propulsion Laboratory, so I can say whatever I want. So we start with a pre-quiz. How many planets have moons? I said planets, and by that I mean major planets for now. All right, and how many moons are there in the solar system? Well, that we're going to need to discuss at some length. If we just count the major planets, there's 206, so we could be here for a while. Which is the largest moon in the solar system? You will learn that in the course of this talk if you don't know already. How do we find moons? Well, we'll discuss that several ways. And which moons have we landed on? I will give you the answer to that. It's only two. One is our moon, the other is Titan. Where do moons come from? Well, we'll discuss that some more later. So let's start with, what is a moon? For our purposes, a moon is defined as a celestial body that makes an orbit around a planet, including the 8 major planets, dwarf planets, and minor planets. There's a distinction, if you haven't been following, between dwarf planets and minor planets, which I'm not going to make here, but they're all little things. So how many moons are there in the solar system? If we just count the big 8 major planets, a total of 206. And in the briefing on Meetup, it said this is changing yearly. It's changing daily. We can't tell what's going to happen from one week to the next as far as moon discoveries, because some of the moons, as you'll see, are coming from old data from 2003. People were still mining to find stuff. So let's start with Earth's moon. I've given a whole talk about this. Earth's moon is unique in terms of planets. It's got the largest mass in relationship to its planet. because of its mechanism of formation, which was from an impact. And this resulted in a larger moon than most planets have. The mass ratio of Charon to Pluto is much higher. It's 1/8 to 1, and we'll get into that a little later. As most of you know by now, we believe that Earth's moon was created from an impact of a Mars-sized object. And the most interesting thing I found out about the moon is from here on Earth, that recent seismology has been able to detect high density anomalies between the core and the mantle of Earth. And these are believed to be the remnants of Theia. So when this planet smashed into Earth, large chunks of it got blown into the sky and reformed into the moon, but large pieces of it are down below our feet as we speak. So let's go to Mars, start with Mars. The idea of two satellites goes all the way back to 1726 in Gulliver's Travels. Jonathan Swift said that Mars had two satellites. Voltaire also said that Mars should have two moons. And the logic of this was since the inner planets had none, Earth had one, Jupiter had four, Mars must have two. I think this was kind of a holdout from Aristotle. If you read Aristotle's Physics, you'll see he was constantly trying to map the orbits of the planet into geometric shapes. And so he thought that there must be some kind of mathematical order to the planets and the moons and their orbits, and therefore the moons. So I think some of that thinking continued. We did not discover them until 1877 by Asaph Hall using the United States Naval Observatory 26-inch telescope. It was later named by George Maiden, an English chemist and teacher. Many of these discoverers didn't get to name their own moons for various reasons. Phobos has been explored, at least at a distance, many times with many of the missions that went to Mars. In passing, they'd catch a picture of or some image of Phobos. And the more especially the Mars Reconnaissance Orbiter was able to get some really good pictures. It's said here that the Spirit rover on Mars saw Phobos, but that was just looking at it in the sky. But they did get a picture of Phobos from the surface of Mars. The Martian's moon exploration is something considered for the future. Here's Phobos from Viking 1. It is 17 miles across, so it's a tiny little thing. It is being dragged down towards Mars. Its structure, as far as we know, is not a solid core or a solid hunk of rock like an asteroid, but it's basically a rubble pile. It doesn't look like that because it's accumulated 100 meters worth of regolith, which is dust and dirt and smaller rocks that kind of make it smooth it over. So it will probably break apart as it eventually, in 50 million years, gets drawn towards Mars. Its origin is unclear. Deimos, also discovered by Asaph Hall with the same telescope. We should mention that each of these two moons, that Deimos has two fairly prominent craters, and they were named for Swift and Voltaire. So the origins of Mars moons could be any of these. They could have been captured asteroids. They could have been formed from the planetary disks. They could have been remnants of multiple moons, which may have collided. There's just not enough data on these moons, and they're a little too small to have a formation and a complex chemistry that we can identify and tell where they came from. So for Mars moons, we really don't know. Deimos, unlike Phobos, its orbit is getting larger. Its orbit is 30.4 hours. Now keep in mind that the Martian day is 24 hours and 39 minutes. So each time you come over the moon, the Deimos has moved a little further in the sky. And so it's five and a half days from one setting to another, much as our moon is 28 days from one setting to another. Moving out to the asteroids. Here's Ida. If you can see over here, it has a small moon. So there's lots of rocks and rubble running around the asteroid belt, but some of them definitely are in orbit around other objects. So if we said moons technically only go around planets, if you want to count asteroids, you could add another 150 to your total of 206. Jupiter, the most recent count is 80. And they range from 1.8 miles wide to Ganymede, which is 3,200 miles, and it is the largest moon in the solar system. 8 of these are regular satellites, meaning they're prograde. They're going around Jupiter in the same direction as its spin, and the orbits are nearly circular. There are 4 that are closer in, and they are very active in contributing dust to the rings. Yes, Jupiter has rings also. And the 4 Galilean moons are round, and they're big enough to be planets if they were in orbit. And the remainder are irregular satellites with all kinds of orbits. Most of those are believed to be captured asteroids. So each of these moons deserves some study. The most recent one was this spring, and this was one that was discovered from data from 2003. The Canada-France-Hawaii telescope had discovered 23 moons previously, and this fellow Kai Lee was an amateur astronomer. You can do this yourself if you want. Went through mounds and mounds and mounds of data and found another a moon that had not previously been discovered. There was enough data to show it was definitely a moon, but they could not determine its orbit. So now we go to our big 4 Galilean moons that we all know and love. There is evidence that Gandhi, a Chinese astronomer, first observed this in 364. Now, how did he do this? He claimed he saw it naked eye. And this was reported by a later astronomer because a lot of his work was destroyed in the change of dynasties. But William Henry Smith in 1844 reported a naked eye observation of a moon around Jupiter. And there have been others since. So it is possible to observe these at least one of these moons with the naked eye. So if you ever get to the Atacama Desert or on top of the Rocky Mountains and you get the right night and the right conditions and have perfect eyesight, you may well be able to see one of the Galilean moons naked eye. Of course, we know Galileo's discovery in 1609. Simon Marius discovered them independently one day later. And he gave the moons the names which we have now. We believe the big moons came from the circumplanetary disk, the big ring of accumulating gas similar to a protoplanetary disk, which created both the moons and Jupiter. We think these were not originally the moons that were created from that disk, that there were probably a score of mass satellites that due to Jupiter's intense gravitation and things being fairly close in, they ended up billiard balling around, getting smashed up and reformed And these may be the 5th generation of moons around Jupiter, which kind of explains why they all look so different, because they may have happened at different times and been made of different stuff that accumulated. So Europa. Europa is very fascinating because its surface is entirely ice, and we believe there is an ocean beneath it that has more water than Earth. There's enough water there to produce disruptions in Jupiter's magnetic field that can be measured. And it may be, well, this is the target of the next NASA mission, which may be 2024, to go to visit Europa. As with all other explorations around Jupiter, it may encounter other moons and other objects on the way. So we look forward to that mission for a lot more knowledge. Io. Io is driven by tidal forces, and particularly Io, Ganymede, and Europa are in orbital resonance, usually 1 to 2. So one of them goes around once, the other one goes twice. And so they encounter each other fairly regularly, and the gravity from the other moons will cause the moon to flex a little bit, just as the water on Earth flexes from our moon. This flexing causes friction, friction causes heat. Water heats up and ends up erupting in geysers and other things, bringing other chemicals, and particularly in Io's case, lots of sulfur to create different compounds to make the landscape around Io. Ganymede, the biggest, it has a big enough to have a magnetic field, and maybe the one that is easiest to see. Callisto is a little bit different. It's further out than the others. It is not in resonance with the other 3 large moons. It's almost the size of Mercury, but only 1/3 of its mass. It has a silicate core and a subsurface ocean. But since it's not subject to the same tidal forces, it appears to be a lot calmer than the other Galilean moons that are erupting geysers and volcanic-like events. So the inner moon, they're called the Almathea group. There are 4 of them. The first discovered by Voyager in by Voyager 2 in 69. Voyager 1 discovered one in 79. It was later imaged by Galileo. And by the way, when I say Galileo, if it's italicized, I'm referring to the spacecraft. If I have it in regular type, it's referring to the astronomer. Similarly with Cassini. Almathea seems to have a disk. Thema was imaged by Galileo. And as I said, these are all more or less circular orbits and close into Jupiter, and are associated with a faint ring system. The irregular moons are much further out, and there's lots of them. What we say, there's 82 minus the 8 that we have, so we're talking 76 moons that have been identified, at least enough to be able to determine their orbit. The orbits often occur in families, so that suggests that they came from a single body that broke apart. So in terms of inclination, which is how far the orbit is tilted, eccentricity, how oval shaped the orbit is, and where the axis of the bodies are, indicate a common origin for each of these families. I'm not going to bother with you, but there's a whole bunch of families. Most of these were discovered by the Canadian-France Hawaii telescope. It's believed that as many as 600 may exist. So you can add that to the 350 we've already enumerated if you count asteroids. So you can be sure that the next, probably the Europa Clipper will discover some more, and we may even discover more from Earth. The inner moons, as I said, are associated with a very faint ring. And these rings were discovered by Voyager 1. And in addition, there are moonlets. Well, what's a moonlet? It's a little small moon. Are we going to count that? Hundreds more if we count those. But there is a very faint ring system around Jupiter that gets both fed from these asteroids, from these moons, and shaped by them. So here's the irregular moons. Oops, back. The ones in red are retrograde. The ones in blue are prograde. And for comparison, here's Callisto's orbit right here. And the other 4 moons are in here around Saturn. So you can see these are way far away. There's so many of them, they haven't managed to name them all. And they're a great variety, and probably almost all captured asteroids. So in a certain way, this may be all space junk that was headed on its way to Earth and could have pummeled us again at some point. Okay, Saturn's moons. The most recent count 82, of which there are 7 large ones big enough to be round. 24 are, again, regular satellites in the same plane as the rings and the equator of Saturn, and going in the same directions. And the rest, the other 58, are irregular satellites, again, with very irregular orbits, highly inclined, retrograde, prograde, elliptical, etc. And they, again, captured asteroids. Some of them may be debris from previous collisions. So within the sprint in the rings, there's 140 moonlets, and many more believed to be there. So you want to count them, keep adding the numbers here. So we're up over 750, I think. So here's our largest moons. Titan, of course, much larger than all the rest. Rhea, Iapetus, Dione, Tethys, Enceladus, and Mimas, each of which has its own story and its own interest.
A quick interruption, Willie. Scott, did you have a question?
Yes, I do. What's the definition of moon versus moonlet? What is the cutoff?
That is a good question, which I have not been able to determine. We've got objects that are called moons that are less than 2 miles in diameter. So who knows? So here is Titan, imaged by Cassini, discovered by Christian Huygens with a 57 millimeter refracting telescope. In other words, he's making these discoveries with a department store telescope. It is tidally locked with Saturn. Its surface is ice. There's, again, water below in a layer with ammonia. It has a dense atmosphere that's mostly nitrogen and has hydrocarbon lakes. Well, anybody who's a biologist who sees nitrogen in the ammonia and hydrocarbon in the lakes and the seas, this is the building stuff of life. So who knows where something strange is going to show up. So Titan's been first explored by Pioneer 11 and Voyagers 1 and 2, and in depth by Cassini. So we know enough with all this study, we have determined that there's a hydrous silicate core, and then a layer of ice 6, which is ice that is so compressed it forms different types of crystals than we would see on Earth when we get our ice crystals such as snow. Above that, a liquid water ocean, then a layer of normal ice, and then some rocks and ice on the surface, and lakes and pools of hydrocarbons. This was the Huygens probe. It was part of Cassini and was released and dropped down to the surface and stopped with rockets and parachutes and landed safely on Huygens and showed us that it looks pretty much like everything else in the solar system, pile of rocks. Enceladus, fairly large for the collection around Saturn, but pretty small compared to Earth's moon. Again, a very interesting moon because of a subsurface ocean. It is again being tidally flexed, which generates heat, which generates pressure, and geysers are shooting salty water into space and in fact create the E-ring around Saturn. It's been explored by Voyager 1 and 2 and by the Cassini probe. It is one of the highest albedo objects on Earth. And there appears to be some kind of tidal action or some kind of tectonic action, because as you can see towards the upper left, there's plenty of craters, whereas on the rest of it, things have clearly been remolded by some kind of motion, probably of ice plates. It's in a 2-to-1 resonance with Dione, as we said. This creates some eccentricity in its orbit, tidal forces, and here's our geysers. Originally, it was thought that these were plumes sticking out, but with better imaging and processing, we can see that they're actually moving. There are actually curtains of stuff coming up along cracks along the surface of Enceladus. Rhea, the second largest moon. Again, another one discovered by Cassini. It probably has a differentiated rocky core. There appears to be some tectonic activity and possible rings. One of the things you'll notice here, as well as in many of the other moons, the craters are not as dramatic as on our moon, and things basically getting flattened at it, and that is because they're basically made of ice. And so you get a mountain like a central peak or the ridge of the crater over time, and we're talking big time, hundreds of millions of years, all this stuff starts to sag back into the surface. And so many of the details that we would see on a rocky moon get lost. It may have its own rings. We haven't been able to image those well enough to determine that, but they're suspected that Rhea has rings. Mimas, discovered by Herschel in 1789, mostly water ice. It is the smallest body in the solar system that is rounded by self-gravitation. Anything smaller than this tends to get a little bit lumpy. And also it is a myth that this was the inspiration for the Death Star in Star Wars. Reason is this image was not that good until 3 years after Star Wars was released. So obviously this moon was copied from George Lucas. Again, it is these larger moons that create some of the gaps in the rings that we see around Saturn. Iapetus, discovered by Cassini, again, a very large impact basin, lots of craters, and a very highly inclined orbit, which suggests that its orbit was disturbed by another planet, possibly in the past. It is mostly ice, 20% rock, and has a number of surface features, including a large ridge around its equator. And its poles are flattened, so people say its shape is basically that of a walnut. Again, our great spacecraft were able to get close enough to image these kinds of features, but we have not been able to explain why this ridge exists. Whether it was from the moon spinning around while it was still somewhat molten and cooled at just the right rate, or who knows what. Also, one side of it is dark. You can see the top of this image, it's in shadow. The bottom part is not in shadow. That is actually the darker side of Iapetus. So again, another Star Wars reference. It has a dark side and a light side. And it's believed that the dark side started as this moon was progressing through some debris, dust and other stuff in one direction, and it accumulated a thin coating of stuff. As time went on, that material melted the ice refroze, and then the darkening increased. And over time, this cycle of accumulation, melting, and reaccretion caused one whole side of Iapetus to become darkened. Dione, another ocean, liquid salt water, 65 to plus or minus 35 kilometers deep. Again, one side heavily cratered and uniformly bright, the other side marked by a network of bright ice cliffs. Tethys, almost all ice, one of the lowest density moons on the solar system. 400, a large impact basin or crater 400 kilometers from diameter. It's believed because of its composition, it was formed from the subnebula that created Saturn. Some of its high albedo comes from the sandblasting from the E-ring. So as we said earlier, Enceladus is shooting salty water into space, and some of this ends up pelting Tethys. And again, it's been imaged by 4 spacecraft. Many more moons, many sizes, shapes, inclined orbits, prograde, retrograde. The shepherd moons help maintain the form of the rings. 150 moonlets in the ring, again, little things, I don't know how small. And many of those moonlets are, many of these smaller moons are in similar inclined orbits. Tethys and Dione have Trojan moons. So they have their own moons that are following them before and after in orbit. Hyperion, one of the larger small moons, has an odd shape, very heavily cratered, and is rotating in every which way at once. So it has a chaotic rotation around all 3 axes. So must have collided with something at some point in the past, and probably most of these others have too. Okay, Uranus, 27 known moons. We know a lot less about them, again, because we have not had spacecraft specifically sent to Uranus to explore them. The inner moons are half ice and half rock, presumably made of the same stuff as Uranus. The outer moons, we haven't been able to determine their composition, but they're presumably captured asteroids. So we count 13 inner moons, 5 major moons, and 9 irregular moons. So inside the orbit of Miranda, we have a ring system. Now keep in mind that Uranus orbit is almost 90 degrees from the plane of the sun, so it's almost pointing toward the sun, which means its rings are facing the sun all the time. And a number of these moons, as in the other planets, are responsible for creating them and shaping them into all the things that can be seen. Only Puck was imaged on the one passage by Voyager 2. enough that we got 3 different craters identified, but that's the best picture we can get of an inner moon from Uranus. The others are all coplanar with Uranus equator, so it means again they're going around an orbit that is at right angles to the sun. Miranda is mostly ice. The others are ice and rock with generally ice on the surface, rocky cores in the middle, and Titania and Oberon contain water oceans at the core and mantle. Here are some of the irregular moons. Most of them are retrograde. Margaret, which is the only prograde moon, has, although it's prograde, it's got the most highly elliptical orbit of any moon in the solar system. None of these axes are coordinated, so they all seem to be captured from different bodies and not a result of collisions and disruptions of other bodies. All these names, by the way, Prospero, you may recognize, Caliban, all the moons of Uranus were named either by from Shakespeare's plays or from Alexander Pope's poetry. I guess they were running out of Greek and Roman names. Neptune's moons, 14 known moons. Triton the largest, and it was discovered only 17 days after Neptune itself was discovered. And Triton, its story is a little different than the other moons. It's believed it may have been captured, and in the process, it destroyed all the other moons in Neptune. So instead of having as many moons as the next 3 inner planets to it, it has 97% of the mass of all the moons around Neptune. So there's 7 inward satellites that are regular satellites, including Proteus and Larissa, which did get imaged, and all but the outer 2 are in a synchronous orbit around Neptune, so they're in the same spot in the sky of Neptune all the time. Again, the inner moons are associated with a ring system, so all 4 of the ice giants have rings and have little moons inside that are creating and shaping them. Probably made of contaminated water ice, some organic compounds similar to the Uranian moons. Irregular moons is another series of names which include Triton, because it's believed to be a captured orbit. Nereid is the only one with a disrupted orbit, so it's believed also to be captured. Triton was discovered by Lassell, imaged by Voyager 2. It has a retrograde orbit, which is why it's considered an irregular moon. Its surface is covered by nitrogen, methane, carbon dioxide, water ice, and a possible subsurface ocean. And we have evidence of that by their presence of geysers in the polar cap. So Pluto, well, 4 moons were discovered, examined by New Horizons. And as you can see, they're quite much larger than Charon. So they're a different species. They are compact, they are circular, they are coplanar, so and it's believed that their origin may be similar to Earth's moon. They have been a result of a collision. The orbits are in complex resonances, not like 1 to 2 in Jupiter's moons, but things like 11 to 23 and stuff like that. And Charon is another bottle of fish because it is 1/8 the mass of Pluto. As a result, its barycenter, that means the place at which both of these things are orbiting, is outside the surface of Pluto. Like on Earth, the center of the Earth-Moon system is not in the center of the Earth, but it's within the Earth, below the Earth. In Pluto's case, it's outside the Earth. So if you had a point here, Pluto would be revolving around here, and Charon would be revolving around the same point. So some people want to consider Pluto and Charon a double planet. It has a red cap, which is believed from the tholins, the organic compounds that that cover much of the surface of Pluto. But wait, there's more. Trans-Newtonian objects. Eris has a satellite. This one was discovered from Earth. And again, a great technological discovery, technological event is adaptive optics, which have souped up all of our big telescopes to an extent that we can discover things that were just not visible before. Haumea has 2 satellites and a ring, which were thought to be fragments of that moon. Makemake has a moon, and several of the others also have moons, etc., etc. I'm not going to be going into that since we'll be here all night. But if you want to do more, just go to Wikipedia. Every one of these things has its own page and a list of references down below that you can find out lots more on. So future missions. Well, the Europa Clipper is being built, and hopefully a launch date of 2024, particularly to examine Clipper and its ocean system and everything around it, and who knows what else it's going to encounter on the way. 2 proposed missions are Trident, which would be to explore Triton, and IVO, the Io Volcano Observer, to explore all that interesting stuff happening on Io. There are some others, but these are the furthest along as far as being actual proposals. So, in conclusion, I did this mainly out of curiosity for myself, and what did I find? Well, there's this enormous variety, not only in terms of sizes, in terms of compositions, in terms of origins, in terms of history, in terms of discovery, in terms of how they were named. It goes on. Each one of these has their own story. So if you want to explore them, there's plenty there. The big finding for me was subsurface oceans are very common. So it makes you wonder how many of those are around exoplanets. In these oceans, what do we look for when we look for life? First thing we look for is water. And the other thing is that we look for is things like carbon and nitrogen and carbon dioxide and methane. These things are all over the place. Life might start anywhere given the right conditions. Earth's moon is special. I'm going to take us off the slideshow for a second because one of the things I think is so special, can you see me? All right, is this.
We can see you.
If you try to spin a pencil, obviously you can't do it. So this is Earth. Spinning things can be unstable. Their axis of rotation can change. But if you take the moon and smear out its mass over time, hundreds of millions of years, it becomes stable. And we believe that, okay, get me back to screen share here, make me go away. start it again. So it is quite conceivable that life on Earth would not exist without the moon, because the moon was able to stabilize Earth's orbit or Earth's rotation long enough for these hundreds of millions of years to happen to allow life to develop and evolve. And where are we? Next slide here. And finally, our heroes, of which are few: Giovanni Dominic Cassini, Christian Huygens, William Herschel, Lasso, several others I mentioned, Asaph Hall, blah, blah, blah. The list goes on. And our list of heroes must also include our robotic friends. Voyager 1 and Voyager 2, that's worth a whole talk in itself, that how we found the determination to get these two up at just the right time when all the planets were lined up in such a way that we could go by each one of them, get a gravity boost, go out to the next one, do some more studies and visit all 4 of the outer planets, and then keep going. And it's what's 30, 40 years now, these guys are still going with their meager 25-watt transmitters, transmitting stuff on interstellar space back to us. And then, of course, other probes since then, dozens going to Mars. Cassini-Huygens, the only one to land a probe on a moon. Juno to explore all of Jupiter and its satellites. So I am now ready for questions, and while we do that, you can unmute everybody. I'll give you this little map to study from our friends at XKCD. This is all the solid surfaces of the solar system stitched together, so you can see their relative sizes and where there is land for sale in the solar system. So you can see Ganymede, the largest moon, up here, and then Titan and Triton. Venus and Earth are about the same size. Here's Pluto and Charon, Eris, Mercury. Again, Ganymede is slightly larger than Mercury. And there's our whole solar system. So, questions?
Randall Schwartz has got a mind on him that I just can't fathom. Marvelous, marvelous.
Willie, your camera is pointing at your desk.
Okay.
Yeah.
Get me back up here. Okay, there we go.
And we have a question from Mark Dillon.
Willie, thank you very much for the presentation. Very fascinating what you covered. I have a question which I can't claim that it's original, because I remember hearing it many years ago at a time when there was not an answer then. And I don't know if there is now an answer to it that you know of. Referring to Titan in the Saturnian system, you had mentioned that Titan has some hydrocarbons on its surface, lakes or seas. We know that that's flammable. We also know that Titan has an atmosphere, so that if there's any kind of bombardment from things like meteorites that would be coming through that atmosphere, and the friction would be lighting them up and heating them up. Do we know why that type of bombardment doesn't hit the hydrocarbon lakes and ignite the moon and cause that moon to self-immolate?
Because we're missing something else. Oxygen.
Oh,
So if you went down to the surface of Titan and had 2 tanks of oxygen on your back and a spark, you would have a rocket. Instead of having fuel, you would have your oxidizer, and the fuel would be in the atmosphere, and you go for quite a ride. So basically, there's just not enough oxygen to create combustion on Titan.
Oh,
Star Party one.
hello.
Public Star Party.
Hello?
Robert has a question.
Yeah, not actually a question. In Greek mythology, Charon is pronounced Charon,
Karen, right.
not Sharon.
That's probably true, although I think Wikipedia said the other both pronunciations are acceptable, although if you know your Greek, it's Karen.
I think even the O is longer. I think it's more like Caron.
Yeah.
Actually true.
Yeah.
Yeah, well, it's all Greek to me.
He was the ferryman on the River Styx.
Really? That I didn't know.
I have no idea what he did with the coins, though.
The coin was the Romans buried each person with a coin on their eye, and that was to pay their fare across the river Styx.
And the Greeks did the same thing.
Yeah, and then another saying that came out of that talked about somebody who was mean and stingy, like he's mean enough to steal a penny off a dead man's eye.
Or actually, in Greek, it would be an oval.
Yeah.
An OBOL. And it's about the size of the iris on your eye.
Cool.
I have a comment.
Crazy stuff.
You mentioned.
How do I clear that?
Can you hear me?
Yep. Go ahead.
Okay. I was at a public star party once years ago, and talking to a teenage girl. We were looking at Jupiter, and she could see 2 moons. So, yeah, and this is not some special conditions. This is just we were out at night and probably good seeing, and she said, "Yeah, I can see this." Like, oh, geez. I was so jealous, you know. I'm looking at binoculars and can barely see them in binoculars, and she's like, "Yeah." She described where they were, and like, "Yeah, that's right." Oh man, but yes, people, if you have 20/10 vision, or a good distance vision, yeah, it's possible.
Very cool.
So Willie, you
Remember the name Gande, Gande, a Chinese astronomer. The Chinese found it first.
What was that, Tim?
Willie, you were talking about the asteroids, and I didn't catch the name. Are you including the asteroids as? So you found there are moons around asteroids? Is that what you were saying?
Right.
And what is is there a name to one of those? You gave a name and I didn't write it down and I missed it.
What was the one?
Well, there's Ida and Dactyl.
Oh, I didn't.
And
Ida.
Dactyl.
Ida. Yeah, it was Ida.
Ida's the asteroid. Dactyl is the moon.
They were okay. Okay. I'm
So
familiar
they,
with
by our definition, a moon has to go around a planet, a minor planet, or a dwarf planet. Those don't count.
Oh, okay.
But they're satellites of the asteroids.
Hmm.
So you can bring your count down below 1,000 now.
So I want to know if there's a name for a satellite of a moon.
I think it's called a satellite of a moon.
and yeah,
But I thought I had heard moonlet used in that context before, but you're saying moonlet is just a small moon.
well, how many of those do we know of?
What?
A satellite of a moon.
So there are a few. I can't remember. There were a couple around Saturn that have Trojan moons.
Well, Trojan means they're in the same orbit as the moon.
They're in the same orbit. They're not orbiting the moon itself.
Right.
But apparently some of the asteroids have moons orbiting around them.
those are moonoids.
Moonoids.
So I,
Meta moons.
if there's not,
If you're a magician, they're mooninis.
Willie, you had an image that was showed the debris from the supposed collision that created our moon.
Yeah,
That was an image of the Earth and the
that's an image of
debris
the Earth.
The core.
Yeah,
core
yeah.
of the Earth, right?
It's a computerized generated image of seismographic data.
Good. Hand that to Bob Berman next time you see him.
now.
Oh, excellent, excellent. Any further questions for Willie?
Okay, well, thank you very much for having me and for propelling me to do this. I sure had a lot of fun learning all this stuff, and I think I know. We had this stuff dribbled at it in bits and pieces over 40 years, and it was nice to get a good view of the whole thing. And the oceans still has me freaked out.
Oh, yeah.
You usually only heard about one or two of them, but they're pretty common, man.
Yeah, I can't wait till we investigate some of those. Those are very, very cool. Thank you so much. All right. Essentially, that brings our official part of the meeting to a close. And if we were in person, we would head out shortly to the diner. But since we can't do that these days, or at least not easily, we just stick around here and chat about whatever you'd like. So feel free to join us, those who are remaining. And you had a good audience tonight, Willie. I think it was about 36 people out there.
All right.
It's tremendous.
Thank you, Willie.
Is there
Yeah.
is there a recording of this somewhere that I can access?
Yes, I was just going to say to Eric,